So if I need to combine calcium and nitrogen, it's going to be something like this. Calcium, which has a charge positive of 2 plus, and nitrogen that has a charge of 3 negative. The first thing that we need to know is which one is the cation and which one is the anion. Which one is the cation? Which one's the cat?
Calcium.
The positive one. Calcium. Therefore, the other one is the anion. So, an anion over there. Okay, just remember, first the cation, then the anion. So what we're going to be doing is, in the first step, we're going to join the elements. Look, calcium. In your periodic table, you can notice that calcium here is uppercase, or the capital letter, okay? And A is in lowercase, okay? That's the way it should be written. If you write, for example, Ca to represent calcium, it's wrong. If you write, for example, Ca to represent calcium, is also wrong. So be careful the way you write the element symbol. So you're going to put together calcium and nitrogen. Remember, nitrogen is uppercase. So you have your charges. Here you have that 2 plus, and here you have your 3 minus. So what is the next step that we do? What do we do with the charges? We're going to crisscross the charges. So that 2 for calcium comes after nitrogen, and the 3 for nitrogen comes after calcium. Okay, so in the end, this is what you have. Calcium 3, nitrogen 2. Now the charges turn into subscripts, and as you can see, the subscript don't have a sign, because the subscript represents the number of atoms. Okay, this is what the subscript represents. So if you put, for example, the negative over there, you are saying that you have negative atoms, and that is incorrect, because I cannot say that I am 50 years old. I can say I am 50 years old. What I cannot say is that I have negative 50 years old. Okay, I don't know if you understand the idea. You cannot have negative 3 glasses of milk. No, when you talk about quantities, the quantity of something is always a positive number. That's why the number of atoms that are written as subscripts are always positive. Always positive. Just remember this. Always positive. Because they represent the number of atoms. And remember what I said in the beginning. The sum of the charges in a compound is always 0. So to check that, I didn't tell this to the other grade, but to check, a compound has charge equals 0. The reason is, or to test it, what we do is to put the number of atoms of each element and the charge that it has as a cation. For example, calcium, here you have 3 calciums, and the charge of calcium okay, so you have 3 calciums and 2 nitrogens. Okay, so what you do to check if the compound charge is 0, I mean, if you did the compound correctly, what you do is you taste the ions. For example, calcium is an ion that has a charge of 2 positive, okay? And nitrogen is an ion that has a charge of 3 negative. So to make sure that it is really 0, we're going to solve individually. 3 times 2 makes positive 6. And here, positive and negative is going to give you a negative number, okay? And 2 times 3 makes 6. So when you perform this subtraction, it's going to give you 0 in the end. So this 0 tells you that the compound that you just formed is correct. That's all it means. Okay? This is a way to check if the procedure that you did is right. Now, this really doesn't matter this much, okay? But you can do it. I'm not against it. But the next process that I want you to learn is how to name the binary ionic compound. So here is the procedure. Take a look. That's the procedure. Only has 3 steps. The first step says that you need to write the cation's name. So to name this compound, first we need to write the cation's name, which means calcium. Then it says, write the anion's root. So you know that the anion is just nitrogen, okay? But it says, write only the root. So to know what the root is, for nitrogen, the root is nitro, okay? So this is the root. And in the last step, it says, change the ending with the suffix IDE. So you're going to get rid of the ending in nitrogen and you will replace it by the suffix IDE. So in the end, the name of this compound is going to be calcium nitride. And the suffix IDE tells you actually that you have a binary compound. Nitride, the suffix IDE, this suffix right here, is only used for binary compounds. So when you read the word, any compound that ends in IDE is telling you that it's a binary compound and that you only need to have 2 ions or 2 elements in the formula. Just like we have right here, we have only 2 elements, calcium and nitrogen. And this is the formula, and this is the name. As you can see, we are learning a lot these days. Okay, we are learning a lot. So you need to be paying attention as much as possible. Now, as a review, how to name the compound. Write the cation's name. Write the cat first. Write the root of your anion, your anion's root, okay? And then change the end by IDE. That's it. Calcium nitride. I'm going to solve another example. I don't know if you have any doubt on this first exercise. If you have any doubt, this is the time where you can ask me. Now this step right here about that you verify the charge of that compound, that is optional. You can do it or not. I'm not going to, or maybe I can be very specific and tell you I want you to do I want you to check this exercise. I want you to check the charge of this compound. Is the charge 0? Could be a true or false question. But the mandatory steps are these ones. Write the cation with the charge, the anion with the charge, crisscross the charges, and then name it. Now I'm going to solve one more example with barium and sulfur, okay? Remember, in ionic compounds, I always combining positive and negative, positive and negative. Not two positives, not two negatives, always positive and negative. So right now I'm going to be forming a compound between barium and sulfur. So this is the second example. There you go. Now tell me, which one is the cation? Which one is the cation?
Sulfur.
Can you read the definition of a cation?
Sorry, barium.
Ah, okay. Remember, that's why well, you cannot look at me, but listen to me. That's why I put it in different order, okay? So in the quiz, I'm probably not going to give it to you in the order cation anion. So you need to know how to recognize. You need to know how to recognize positive from negative. So barium is the cation and sulfur is the anion. The reason is the charge. Here is negative and here is positive. Okay, so according to the rules that I gave you, which element is written first?
Barium.
Barium is going to be written first. And please do not forget the charge, so I'm going to put it here. So after barium, I have my sulfur. And my sulfur has a charge of 2 negative. And then the rule says that you have to crisscross the charges. That's what the rule says. Okay. So after you do that, you're gonna have like this, the 2 from sulfur here, and the 2 for barium over there. But here is when it comes as a very special case. And to explain you this rule, I will remind you that in your math class, when you learned about fractions, you learned how to simplify fractions. For example, if I tell you a fraction that is 4/2, can you simplify it? A fraction 4/2, you simplify, you say, okay, it is divisible by 2, so 4 divided by 2 is 2. And 2 divided by 2 is 1. In the end, you ignore 1 and you just write a 2. That is a procedure that we know in math as simplifying fractions. Now, a different example. What if I give you a fraction of 2/2? What happens in a fraction like that?
Is 1.
2/2, divide by 2 each, so you're gonna have 1/1, and you ignore 1 as a denominator, so this is just 1. So this, what I just did right now, is what we know as simplifying fractions. Now in chemistry, we're gonna use it. We're gonna simplify, but not fractions. We're gonna simplify a number of atoms. So here, imagine that this is the same as having a fraction 2/2. So what are you gonna have in the end? You're gonna have 1. And what happens when your subscript is 1? What do you do with 1? What happens with 1 as a subscript? It is written in the rules that I gave you last week.
You ignore it.
You ignore it. Pim pam. You erase it. You don't need to put it there. So, as a rule, when you have ions that have same number but different symbol, you just cancel them and you ignore them. Because you cancel them, you don't need to put them. I mean, all this procedure that I did over there is not necessary. I mean, you can, with both procedures, you can go to the answer. But I always choose the easy way. The easy way is to ignore the charges. I'm not gonna put them as a subscript because they are the same charge. It's like my students used to say, "Ah, no, miss, yo lo que hago es que lo cancelo," and they do this. It's fine. In the end, this is what you get. For me, it's okay if you do that. Okay? So, you can cancel the charges, you can ignore the charges, or you can do all the process and in the end, simplify the charges. It doesn't matter. In the end, this is going to be your final answer. And then we have to name it. So, according to the rules of naming, what will be the name for this compound? What is going to be written first?
Barium.
Barium. And then? From sulfur, what is going to be the root that I'm going to take? What is going to be the root for sulfur?
So,
Sulf. Okay? This is going to be the root. So, according to the rule, I choose the root and I get rid of the rest and I replace it by the suffix I, D, E. So, in the name, in the end, the name is just going to be barium sulfide, like that. So just read it like you do, like you normally read. Okay, you read from left to right. What you read in the left is Ba, which is barium. What you read in the second is the S for sulfur. But remember that you changed the ending, so instead of sulfur, it will be sulfide. So it's going to be read as barium sulfide. Now, in the table that you have here, you can notice that we have elements that have that can form multiple ions. Like, for example, iron. Iron can either use 2 plus or 3 plus as a charge. So what can we do if I, for example, want to combine iron with oxygen? So to tell you this, I need to do I need to combine it. So how can we specify what iron is the one I'm using? So this is where it comes the next topic, that is called multiple valence electrons for cations, that in this case refers to transition metals. So the naming for this topic, or this kind of elements, is going to this kind of compounds is going to be binary ionic compound, but with transition metals. So let's say that I want to combine, as I already told you, I want to combine iron 3 plus with oxygen, which is 2 minus. So how can I form the compound? The compound is being formed in the same way. So you just put them together and you get your trail over there. It's very ugly. And then what happens with the charges? The charges, you have 3 plus here and you have 2 minus over there. So the charges, how is the compound going to be formed? I mean, the 3 for iron, where am I gonna put it?
and oxygen.
The 3 from iron comes to oxygen, okay? And the 2 for oxygen comes to iron. That's the compound. Very simple. The compound is very simple. But then comes the naming part, okay? Then comes the naming part. So, what happens here? How can we name it? Take a look at the rules. Here I included an extra rule for this. It says the first one is the same, write the cation's name. In the second one, it says write a charge in Roman numerals. Because iron has multiple charges, as you can see here in this periodic table, you need to indicate the charge. The way to do it is in Roman numerals. So this iron actually is not just called iron. This is called iron 3 because the charge is 3. And the reason it is written like that is because it is a transition metal. It's a transition metal, but with multiple charges. That's the reason. So the name for this one is going to be iron. You need to specify the charge of iron, not the atoms. This one, no. Okay, the charge of iron. The charge is seen right there, the one with the symbol. Okay, so the charge is the one that has the symbol, so it is iron 3. And then you have the second element, the anion, that is oxygen. What is going to be the root for oxygen?
Oxy.
Ox.
Ox. Yeah, it's very tricky. That's why I'm doing several examples, okay, with different anions. For oxygen, the root is going to be just ox. And the rest is going to be replaced by the suffix -ie. Okay? So in the end, the name is going to be iron 3 oxide. Interesting. I mean, the procedure, as you can see, is the same. But what changes is the iron, because iron is a transition metal. Now, what happens if I want to combine the other iron instead? that I want to combine, for example, iron 2 with oxygen 2 minus. So what is going to happen here? What is the first step that I have to do? First, I notice that iron is a transition metal. And I notice that the charge is 2 plus. So what I do right now, because iron is a special element, is transition, I'm just going to call it by the name. This is not just iron. This is iron 2. Okay? So I am combining iron 2 with oxygen. In the end, I'm just going to join the two cations, iron and oxygen. So there you go. You have your ferro over there. Ugly one. Okay. So what happens with the charges? Take a look to these charges. What is going to happen with those charges?
Cancel them.
You are going to cancel the charges. The reason is because you have the same charge but with different signs. So in the end, you just cancel the charges or ignore the charges. Remember, what happens if you subtract 2 with 2 is going to give you 0. So 2 minus 2 is 0. So in the end, you don't need to write the subscripts. This is the compound that is going to be formed. So the procedure of forming the compound is not very complex at all. But here in the naming part, it turns to be more interesting. So how are we going to name this compound? It says, write the cation's name first, and then write the cation's charge. So what is going to be the name of this? Fe, that is iron. What is the charge of that iron? What is the charge?
2.
The charge is the one with the symbol, and the symbol is 2 plus. So that 2 goes in Roman numerals. And then what happens with the oxygen? Oxygen turns to be what is my root?
Ox.
Just the ox. And then you get rid of the rest and you replace it by IBE. So the name for this compound is going to be iron 2 oxide. So take a look. All the procedures actually are very similar. But you need to be aware of the formulas, okay? And how the formulas are going to be named. So remember, binary compounds end with the suffix IDE. I'm going to send you a homework for you to practice this topic. If you have any doubt, you can ask me.